Marilyn hit a golf ball on the ground with her driver. Use the general function for projectile to write a function that shows the height in feet of her golf ball as a function of time. The ball was hit with an initial vertical velocity of 100 feet per second, so how long will Marilyn's golf ball stay in the air? So first our given. So we know that gravity is equal to negative 16 t squared. The initial vertical velocity is equal to 100 feet per second. And the golf ball was hit from the ground, so the initial height was 0. And so from the projectile motion equations, the only one that applies to vertical velocities is this first one. So from the projectile motion equations, the only one that includes vertical velocities is this one. So if we plug that in, we get h of t equals negative 16t squared plus 100 t plus h. And in this case, h is 0. And we can say from the question, how long will Marilyn's golf ball stay in the air, that that's the same thing as asking how long it takes before it hits the ground. So we can just assume that the height is 0 because we want to know when it hits the ground. So this is going to be our new equation, t squared plus 100 t. And so next we can use the quadratic formula, which is x equals negative b plus or minus the square root of b squared minus 4ac over 2a. So first let's lay down our variables. A is equal to negative 16, b is equal to 100, and c is equal to 0 because there's no c value. So when we replace t for x, we get t equals negative 100 plus or minus the square root of 100 squared minus 4 times negative 16 times 0 divided by 2a, which is negative 16. So then we get, when we simplify that, we get 100 plus or minus the square root of 10,000. And if we simplify this, it just comes out to 0, so this stays the same, divided by 2 times 16, which is negative 32. So we know from the discriminant, if it's above 0, then it's going to have two solutions. So if we simplify this, it will give us 100 plus or minus 100 divided by negative 32. And so if we subtract negative 100, then we get negative 200 divided by negative 32. And we also get 0 divided by negative 32. So our answer for this is 6.25 or 25 over 4. And then this is obviously 0. So we get time equals 0 and time equals 6.25. And this represents when the ball was launched and when the ball hits the ground.